Hello guys, welcome back. So in the last video I mentioned there is a serious flaw in this edit distance program. So let's see what is it. So now I am trying to increase the string length. Okay, so this is my string length, and now again I have increased the two string lengths. So now I have to find the minimum number of edits required to convert string 1 to string 2. So if you try to run the program, you won't get the output. Just like for Fibonacci of 45, we didn't get the output for 5 minutes. Okay, in the same way, whenever you are increasing the string length, you are not getting the output. The time to calculate the output increases exponentially whenever you keep on increasing the length of the string. Okay, so what is the solution for this? We know that we have to apply caching technique. So let's try to write a cache. So what is the basics of this? Caching is int cache of. So what is the size we have to store? Okay, so that comes the question. So the size of the cache will be given. Okay, when in the edit distance problem, the inputs string 1 and string 2 lengths will be given. So if I say the string 1 length won't be greater than or equal to 100, so the string 1 length will be in between 1 to 100 now, or string 2 length will be in between 1 to 100. So the length of the string won't increase beyond 100. Okay, this is the input that I am giving. So the cache size will be 101. Okay, and one more important thing. So in the recursive function, you should always have a variable parameters over here. Okay, so you should not have a non-varying parameters. Okay, a parameter which is constant should not be present in this recursive function. Okay, it can be present, it's not an issue, but the thing is, let's write a clean recursive function. So whatever the parameters that are written in the recursive function, that should be a varying parameters. So for example, I can write like this. Okay, string 1 comma str2. Okay, the recursive function can also be like this, but string 1 and string 2, they are not varying, they are constant, right? Only what are varying, the lengths that we are passing over here, that are varying. Okay, so only the varying parameters should be present in this recursive function. Okay, based on this varying parameters, your cache dimension will be. Okay, if there is a single varying parameter just like this, so the cache will be 1D cache. If two varying parameters are there, so the cache will be 2D size. Okay, the cache is two dimensional. If there are three varying parameters, int s2 length, then for example s3 length, okay, then the cache will be 3D cache. Okay, based on number of varying parameters, the cache dimension will vary. Okay, for example, if I have 5 varying parameters over here, okay, sy length just like this, okay, then I will have 5D cache. Okay, this is the key important thing. So always have varying parameters in the function, and you have to define a cache dimension based on variable parameters. Okay, this is the important thing. Okay, so for example, here we have only two varying parameters, so we are defining only 2D cache, and these two strings, okay, these two strings length won't be greater than or equal to 100, that we have defined in the question itself. So I am defining a cache of 101, right? So we have to set up the init the cache. Now set up the cache. Okay, we have declared the cache. Now we are init in the cache. Okay, though this is the rule that I have explained in the Fibonacci series also. Int I is equal to 0, I less than 101. Okay, I plus plus 101, I plus plus for int j is equal to 0, j less than 101, j plus plus, and set cache of I of j is equal to -1. Now you have to define that cache in the main function. You have initiated the cache now. So what you are going to do? So whenever you are returning the answer, you store that into the cache, right? For particular S1 and S2 length states, okay, for particular S1 and S2 length, you have calculated one answer. This is that answer, and you are storing that answer into the cache before returning. Okay, now whatever the answer you have stored, you are going to return now. Okay, if cache of S1 and cache of S2 not equal to -1 means you have already solved for that particular state. For S1 and S2, for that particular state, you have already solved the answer and kept it in the cache. If it is not equal to -1, you are returning the answer from the cache itself. Okay, so you are trying to avoid the problem which is already been solved. Okay, now if you try to run, you will get the answer in few milliseconds. Okay, here is the answer. So it requires 27 edits to convert string 1 to string 2. Okay, clear? So the main important thing that you have to remember from this video is you should have only variable parameters in the recursive function. That is the reason why I have defined string 1 and string 2 as a global. Okay, so in the competitive programming, global variables are allowed, and based on that I have declared them in the global. Okay, so don't try to declare a constant variable in the recursive function. Only varying parameters you have to declare in the recursive function, and number of varying parameters will decide the dimension of the cache. If it is 2 variables are there, 2 dimensional. If it is 3 variables, 3 dimensional. Okay, if it is n variables, n dimensional cache you have to set up. Okay, and you have to store the cache that S1 and S2 for a particular S1 and S2 values. You have to store the result into the cache, and again if you are being asked to solve the recursive problem for that particular S1 and S2 state, don't try to solve it, you just return it from the cache if it is not equal to -1. This technique I mentioned you, this is a memoization and it is a top down technique. Okay, if you observe the cache, so the answer is 27, and if you observe the cache over here, the answers are being calculated and stored in the cache. Okay, fine. Let's catch you in the next video with a new DP problem. See you, have a nice day.